Hello there and welcome to the October 2020 paper. Here we're looking at question 6. So A is equal to this matrix here, 2A, A minus 4B, where A and B are non-zero constants. Given that the matrix A is a self-inverse, determine the value of B and the possible values of A. Now if it's a self-inverse, then what will happen is A will multiply by A to give you I, but it's effectively inversing itself and to give you I, because remember when you times A by the inverse, it gives you I. So we've got two different methods of doing this question. You can either do method 1, which is find the inverse and then set the two things equal to each other, or what you can do is you could times the two matrices together and set it equal to I. I think what I'm going to do here is I'm just going to times the two matrices together. So it's 2A, A minus 4B, and then times by itself again, 2A, A minus 4B, and this is going to equal 1, 0, 0, 1. So let's multiply out the matrix. It's going to be 2 times 2 is 4, moving across and down, that will be plus A squared minus 4A. Moving on to the next cell, it's going to be 2 times A, will be 2A, moving across and down, plus AB. Moving on to the next row and this column here, so it would be 2A minus 8, and then across and down, plus AB minus 4B, and then on to the last one, it's going to be A squared minus 4A plus B squared equals 1, 0, 0, 1. So let's now pick which cell. I think it would be more easier to work out. I think if we pick the top left cell on the left and the right hand side, then we'll be able to work out what A is equal to. So it's going to be A squared minus 4A plus 4 equals 1. I'm comparing this cell here with this cell here, because if the two matrices are equal, then the matrices in the relevant positions must be equal to each other. So it's going to be A squared minus 4A plus 3 equals 0. So if we now factorize it, A minus 3, A minus 1, we're going to get A equals 3 and A equals 1. Okay, so now for these two values of A, we've now got to work out what B is equal to, and I think the easiest way of doing that will probably be to use the top right hand cell. So if we use the top right hand cell, that's going to give us 2A plus AB equals 0. Let's start off by using A equals 3, so that's going to be 6 plus 3B equals 0, so therefore B equals minus 2. And then when A equals 1, it's going to be 2 plus B equals 0, so therefore B again is going to equal minus 2. So there we are, in both cases there, B equals minus 2, so that's the value of B, and the value of A is 1 and 3. So there we are, that's the answer to part A. Let's now move on to part B, so let's just make a note of that. A was 1 and 3, and B is minus 2. So the matrix A represents a linear transformation M. Using the smaller value of A from part A, show that the invariant points on the transformation M form a line stating the equation of that line. Now what an invariant set of points are a set of points that don't move under this transformation. So if I write out first what this transformation is, A is going to be using the lower value of A, 2, 1, minus 3, minus 2. That's our transformation. So our matrix A, our transformation M. Now, if we want to show that there are some linear points that form a line, what's going to happen there is we're going to do 2, 1, minus 3, minus 2, that will transform the line y equals mx plus c. This is a straight line, but remember all straight lines that are going to be invariant are just y equals mx, because the point 0 is never going to move, so it has to go through 0, 0. So it's going to be the coordinate x, and then the y coordinate is going to be mx. And then if it's invariant, then what that means is that this coordinate here will not move. So therefore it's going to be x, mx again. you can see here that the coordinate has not moved after this transformation of 2, 1, minus 3, minus 2. So let's expand the brackets on the left hand side now. It's going to be 2x plus mx on the top, and again that's going to equal x mx on the right. On the bottom it's going to be minus 3x minus 2mx, and that's the bottom. So now what we can do is we can compare the top row and the bottom row and work out what m is going to equal. Oh sorry, I think I've just worked this out a bit. This should be an x there. So on the top row it's going to be 2x plus mx equals x. Now it doesn't really matter that x is, we can just cross out the x's here and put 1 there. So it's going to be 2 plus m equals 1. So therefore m equals minus 1. Let's just make sure that's the case with the bottom one as well. So it's going to be minus 3x minus 2mx equals mx. We can cancel out the x's because that's just the point 0, 0. So it's going to be minus 3 minus 2m equals m. So if we now move that to the other side, we're going to get minus 3 equals minus 3m. So therefore m equals minus 1. So plus, because you add it to the other side. So m equals minus 1. So therefore, stating the equation of the line has equation y equals minus x. And there we are, that's the answer to part B. Moving on to part C now. Now part C doesn't really have anything to do with part A and B. So we have a new matrix P, 2p minus 1 minus, so 3p, where p is a positive constant. The matrix P represents the linear transformation U. The triangle T has vertices at the points of 1, 2, 3, 2, and 2, 5. The area of triangle T under the linear transformation U is 15. The area of the image of T under the transformation U is 15. Work out the value of P. So let's just visualize what we've got here. So I'm going to draw out triangle T on this grid here. So the coordinates will be 1 across 2 up. That would be 1, 2. The next coordinate will be 3 across 2 up. And then it will be 2 across 5 up. So let's work out what the area of the triangle is before the linear transformation U. So it's going to be 2 on the base and 3 on the height, because it's going from coordinates 2 to coordinates 5, so it'll be 3 on the height. So therefore, the area of this triangle is going to be base times height divided by 2, which is equal to 3. So the area T before the transformation is equal to 3. And now what we're going to do is we're going to use the bit of maths that the determinant of the matrix is equal to the area scale factor. So the area scale factor was from 3 to 15, so the area scale factor must be 5. So therefore the determinant of the matrix must be 5. So now I've got to work out the determinant of the matrix. So it's going to be bit cross multiplying there. So it'll be p times 3p, that would be 3p squared, and then minus this as multiplication there, so that would be minus 2p. That will equal 5. So it's going to be 3p plus 3p squared plus 2p. I'll take away the 5 onto the other side, equals 0. Let's now factorize this. It's going to be 3p and p equals 0. So let's now factorize. It's probably going to be minus 5 on this side, and so plus 5 on this side and minus 2 on this side, and that will give me the, so no, that's not going to work either. Oh, it's plus 5 and minus 1, silly me. Don't know where the 2 came from. So it's going to be 5p and minus 3p, so that would be 2p, yeah, good. So therefore p is either equal to minus 5 over 3, or p is equal to 1, but given that p is a positive constant, so therefore we can deduce there that p must equal 1. Okay, so there we are. That's the answer for part C. Let's now move on to the next part. So just a reminder that the matrix P, I think we need it for this part here, is going to be, if P is 1, it's going to be 1, 2, minus 1, 3. So 1, 2, minus 1, 3. So the transformation V consists of a stretch of a scale factor 3 parallel to the x-axis and y invariant, followed by a stretch of minus 2 parallel to the y-axis and x-axis invariant. That's quite a complicated transformation there. Actually, the matrix C of it is really easy. The transformation V is represented by the matrix Q, so it's first going to be stretched by a scale factor 3 in the x-axis and minus 2 in the y-axis, so it's just going to be 3, 0, 0, minus 2. That's the matrix Q. Moving on to the next part, given that U followed by V is the transformation W, which represents the matrix R, find the matrix R. Now this is testing the bit of maths that if you're applying these two transformations, you need to multiply the matrices in the reverse order. So given that U followed by V is equal to transformation W, so we need to multiply these matrices in the reverse order. So it's going to be 3, 0, 0, minus 2 times 1, 2, minus 1, 3. This one here is representing transformation V, this one here is representing transformation U, and we're multiplying them in the reverse order. So let's do the multiplication now. So it's going to be 3 times 0, so 3 add 0 is 3. 3 times 2 is 6, and then add 0, so that'd be 6. 0, that'd be 2, and then 0, and then minus 6. So there we are, this is matrix R. And there we are, that's the answer for this question here. So 16 marks for that question in total there. That's the answer to question 6. Let's now move on to question 7.